water weighs less than air. Water weighs less than air. Seems wrong, but isn't it? It always seemed counterintuitive to me, but it is the case. Consider if you had a box of golf balls. If you weigh the box, it might weigh 20 kilos. Substitute a few of the golf balls for the ping pong balls, the weight might then be 15 kilograms. So it's taking up the same amount of space, but it's weighing less. Okay, so if you like, the density is less. And the same is true for wet air. So water allows density. Atmosphere is mostly made of nitrogen and oxygen, as we all know. The atomic weight of nitrogen is 14, atomic weight of oxygen is 16. Generally both of those exist as an N2 molecule and an O2 molecule. Okay? So the weight of nitrogen in the atmosphere is generally about 28, and the weight of oxygen is about 32. So if you know the percentages or rough percentages, then a box of air might weigh, I don't know, let's pick bulldozers, 28.8 bulldozers. Okay? Water's made of hydrogen and oxygen. So the chemical similar as we all know is H2O. The atomic weight of hydrogen is 1, atomic weight of oxygen is 16. So together they weigh 18. So if you substitute water molecules for air molecules, then you're introducing ping pong balls into the box of golf balls. Okay, the water takes up the same space in the atmosphere, but it displaces the oxygen and the nitrogen. So a lower weight displaces a higher weight. Ping pong balls displace golf balls. So that lowers the density. So taking off on a hot day at sea level can be the equivalent of taking off at a higher altitude on a colder day. Because remember, as the pressure goes down, the density goes down. So it's possible to calculate what your equivalent altitude will be if you take off on a hot day, and I'm sure you've probably all seen a density altitude charts. I thought it was a good picture. Cold, dry day at sea level, aeroplane takes off easily. Hot, humid day at 5,000 feet, lack of lift, and he embarrassed himself in front of other people.
Most jumbo jet pilots would know that though, wouldn't they?
They've generally got a fair idea. They've done a bit of training by the time they get to that stage.
They get some little electronic device that tells them.
Well, actually, we need to get phone calls going to work.
Sorry, I can tell you when in South Africa, the Johannesburg is at about 4,300 odd feet. And flying back with Qantas, we taxied out, and they actually plan their takeoffs in the evening when it's cooler. And when we taxied out, the captain came over the PA and said we had to wait for the temperature to drop about 2 degrees before they could take off. According to their standard operating procedures, they got a minimum temperature. We sat there literally waiting for the temp to drop. So they do. They're pretty. And Joburg at 4,300 odd feet on a close to 30-degree day, which is pretty common. You're looking at a density altitude of 8,000 odd feet. So your aircraft will be performing as if it'll think it's at 8,000 feet.
Yeah.
It makes quite a difference.
And I guess the other one, I'm going to throw one in that some of us know. A few of us went to Mungo last year, and since we were there was a guy that crashed, certainly up that way somewhere, in a Eurofox. Days we were there, he had plenty of runway to spare, but that guy crashed. He was, for being there at a hotter day,
lift.
person on board, he didn't make it.
So that just stalls the plane then, if you're flying in, or?
Yeah, well,
You just struggle to get flying speed. It's just one
you need more air, so you need more speed over the wing
Yeah.
to get the lift.
To keep the lift to come and land.
Well, or to take off, clear the trees.
Yeah.
It's in the airport. Japan Airlines used to monitor pretty closely what the temperature was, because at that stage when I was there, they still had 747-200s, I think they were. And if the temperature got above 35 degrees, they had to start throwing passengers and freight off the plane.
Oh, right.
Not on a takeoff front.
Bump things.
No.
There's a guy standing at the back. That's not happening. Throw more.
Lots of expendables on those flights. So density altitude doesn't just affect your takeoff, it affects your rate of climb and general aircraft performance. It's pretty well shown. So quick recap, best case is cold air, worst case is warm moist air. So for example New Guinea and Northern Territory in the wet season, which obviously you're not going to see a lot of. But we're moving into summer now, so we're moving into warmer days, and particularly if you fly a little bit inland, the temperatures are 40 or 45 degrees or so, the density altitude is going to be much higher, so you're not going to have as much lift as you'd expect. So it's worth being mindful of the possible dangers of being overloaded, not being able to achieve a satisfactory takeoff or rate of climb. And that's why, as I said, the major airlines expect, or they request expected maximum temperatures, and that's why some of the overseas TAFs, for example China, I think some of the places in Southeast Asia, they actually have an expected max temp in their TAF, and that's for planning purposes. So that's all I've got on density altitude. It's pretty simple. It's a matter of just monitoring what it's like on the day and being mindful of it. They've come up with a new thing that I didn't know about, so I had to look it up last night. They're using Southern Annular Mode now, SAM.
What's that?
I've never heard of it. I mean, I've heard of
Maybe Google that.
Southern Oscillation Index and Indian Ocean Dipole. They're sort of well known about, but they've started using this one, so I looked it up. Southern Annular Mode, or SAM, is a climate driver that can influence rainfall and temperature in Australia. Refers to the non-seasonal north-south movement of the strong westerly winds that blow almost continuously in the mid to high latitudes of the southern hemisphere. Talking about this.
Yeah, there's been a bit of stuff going on there. The thing over Antarctica.
Oh, the southern tropospheric warming.
Yes.
Yeah. Stratospheric warming rather.
Yes.
Yeah. What that does is it warms, the stratosphere is just above the troposphere, so that warms there, and what that means for us is it actually provides warmer air aloft, so there'll be less moisture available, so it actually makes it drier in Australia. So everything's working against us at the moment. It's got to flip over at some stage. It has to flip over eventually.
As the temperature, thinking about the equator, as the temperature increases with the humidity at the equator, do you get more movement of the air from the dry south towards the equator?
Well, you can.
So that we're taking more moisture away?
You can. That's actually the mechanism for the Indian Ocean dipole. It actually moves across here. And if it gets warmer in our part of the world, then you get more flow.
It sucks it in.
It sucks it in, if you like, so you get more moisture in northwestern Australia.
Yeah.
And we see that here when we get these big bands of cloud across central Australia, and they feed moisture into our systems. So when the Indian Ocean dipole is strongly positive, that means that we're going to get a lot of moisture. But at the moment it's strongly negative. I think that's what it is.
Well, it's just going to go
So
back, and they're
not-
talking about an El Nino starting across the equator, don't they?
Yeah.
South America.
Yeah, well, it's, the El Nino, the El Nino actually starts. There's a flow across the Pacific called the Walker circulation, and what that does is there's always a general flow with the trade winds from South America to our part of the world, but particularly northern Australia, I suppose. But it affects all of us. And what that does is that wind blowing across the ocean blows the surface of the ocean off and away to the east, so the cold water underneath wells up, and that's a normal situation where we've got lots of moisture transferred across the Pacific. What's happening is that's dropped a little bit, and I don't know, but I would presume that the anchovy catch off South America's down a bit too, because what happens is that if the water stays warm there, the anchovies don't go to the coast of South America. That's how they first discovered it. So if that flow breaks down, then there's less moisture transferred across the Pacific, so then we end up with less rainfall across the eastern seaboard, in particular of Australia, and our